Welcome to this video. We will be going over the predicted paper 2 calculator for the higher tier. This paper has been put together by Third Space Learning. This paper is in the format of the Edexcel exam board. However, AQA students can use this paper. They just got to bear in mind that their questions may be in a slightly different format. So the topics will be the same, the methods will be the same, but the format, the layout of the questions will be slightly different. For example, you may have some multiple choice questions. There are a total of 21 questions on this paper, so we'll start at the beginning and then work our way to the end. Make sure you write down some good notes, and if you haven't checked out the paper 1, do go and check it out, and after this paper I'll be doing paper 3 as well. So let's get right into it. For question number 1, this scatter diagram shows information about the cooking times of a variety of cakes. Here is some information about another 3 cakes, and you're given this table. Plot this information on the scatter diagram. So what do we want to do here? Well, first of all, just identify the fact that you've got the mass here and you've got the cooking time. So the mass is referring to the x-axis and the cooking times are referring to the y-axis. So you've got to plot these points on there. So if you do the first one, 750 is the mass and the cooking time is 35. So you find 750 here and you go and find 35 here. So 35 will be halfway point between the 30 and the 40. That will be right there. So we can put a mark right there. So 750 and 35 right there. Okay. Next one is 850 and 50. So once again, you go and find where 850 is. It's right there. And you're going up to 50. So you're going to mark it right there. Okay. There you go. Next, 700 to 20. So go and find 700. 700 is here and 20 right there. Now the question goes on to say, what type of correlation does this scatter diagram show? So as you can see, your points are going up, and that is a positive correlation. So positive correlation. If your points are going down, then that would be a negative correlation. And if they're not going up or down, they're like this, they're all over the place, that is no correlation. Okay, but in this case, it's positive. For part C, it says use a scatter diagram to estimate the cooking time of a cake which weighs 900 grams. And this is 2 marks. Now, one thing that these questions often don't tell you is to draw in a line of best fit, because you can only do this with a line of best fit. Students often, they just go and find, the weight, 900 grams. Okay, they find it here, and then they go up and they just estimate things across. You can't be doing that. You have to draw your line of best fit. Okay, so what is the line of best fit? A line of best fit is a line that goes as close to as many points as possible. It doesn't actually have to go through any point, by the way, okay? But it goes through as many points as possible. Now, one of the mistakes that students often make is they always think that the line of best fit has to come through this origin, all right, or this corner, all right? So they always find, the line has to go like this or like that, okay? No, it doesn't. Line of best fit can come and just cross the y-axis wherever, okay? Remember, your focus is to make sure that your line goes through as many points as possible. So the one that I just did right there, that was quite reasonable, would you say? Yeah, so you can just put that in, something like that, okay? Make sure you get a ruler and go through. All right, so that's pretty good, I would say. So let's use that as our line of best fit, because as you can see, we have an equal distribution of points on either side of the line as well, okay? So now what we want to do is go and see where our 900 is. So 900 is right there. And then we're going to draw a line up to our line of best fit, like that. And then we'll see where it hits, and it hits about, and again, this is an estimation. So around, I would say, halfway between this box. So now I have to work out what each of these boxes represents, okay? So I've got 10, the difference between 40 and 50, and I've got 5 boxes in between, which means that each box is worth 2. So 2, 4, 6, 8. So this would be 49, okay? So you'd say 49 minutes. Now, some of you may get a different answer, and this all depends on how you drew your line of best fit. The examiners will give you a range, okay? So let's say the range would be something around 46 to 50. So anything in between that, that's fine. Question number 2, here is a rectangle and a trapezium. The area of the rectangle is 40% greater than the area of the trapezium. Work out the length of the rectangle. Okay, so the length, let's go and mark the length. Let's call it x. So that's the length of our rectangle. Now, what we're dealing with, we are dealing with area. Okay, so we want to find the area of both our rectangle and our trapezium. So the area of the rectangle is going to be the length times the width, and that is x times 4. So that's going to be 4x centimeter squared. That's the area of our rectangle. How do we find the area of our trapezium? Well, the area of the trapezium is a plus b, which are the two parallel sides, divided by 2 times by the height. So a, b, we can say that's a and b, the two parallel sides, and h is 4 centimeters, the height. So let's put that in. So that's going to be 6 plus 9 divided by 2 times by 4. And you can work this out on your calculator, and that gives 30 centimeters squared. So that is the area of our trapezium. Now, let's go and look at this, 40% greater. We are told that the area of the rectangle, which was what? 4x, is 40% greater than the area of the trapezium. So the area of the trapezium was 30 centimeters squared. So 40% greater than that, we can use a multiplier. So a multiplier of 40% greater is going to be 1.4. Okay, if you need help on understanding multipliers, I do have a separate video on percentage multipliers on the channel, so you can look that up. Because it's 40% greater, we add the 40% to the 100% and we get 140%, and then we divide that by 100 to give us 1.4. If it was 40% less, then we take away 40% from the 100%, and that would be 100, take away 40, which is 60%, and then we divide that by 100, and that gives us 0.6. So if the percentage was 40% less, it will be 0.6, the multiplier. But in this case, it's 1.4. So 1.4 of 30%. Of means to multiply, so we can have that. So 1.4 times by 30. And that gives us 4x on the left-hand side. And 1.4 times by 30 is 42. So now we want to find out what x is. Remember, what is x referring to? Just a quick reminder. It's referring to the length right there. Okay, and the length of the rectangle is what we are trying to work out. Okay, so we are going to do x is equal to 42 divided by 4, and that gives us 10.5 centimeters. So that's our length of rectangle. Okay, question number 3. A box holds 12 donuts. Let's highlight that. It takes 500 grams of flour to make 20 donuts. Linda needs to make 4 boxes of donuts, and she only has 1.5 kilograms of flour. Does Linda have enough flour to make 4 boxes of donuts? Let's start off with the fact that Linda needs to make 4 boxes. Okay, so Linda needs to make 4 boxes of donuts. So what is 4 boxes? If a box holds 12 donuts, then that means it's going to be 4 times 12. And that gives us 48 donuts. So this is how many donuts that Linda will be making. Now, she only has 1.5 kilograms of flour. We want to know whether she has enough flour to make these 4 boxes of donuts. So it takes 500 grams of flour to make 20 donuts. Now we want to make 48 donuts, but we've got this much amount of flour. Why don't we find out how many donuts you can make with 1.5 kilograms of flour? So how many 500 grams go into 1.5 kilograms? 3. Okay, so 3 times 500 grams gives us 1.5 kilograms. So that means we can make 3 lots of 20. So 3 lots of 20 gives us 60 donuts. We can make, well, Linda can make 60 donuts. So therefore, it's more than enough for 48 donuts. So our final answer is yes, she can make 48 donuts. And there you go. Okay, so question number 4 for 3 marks. Solve the simultaneous equations. First thing you want to do is label 1 and 2. Then you want to decide what letter you want to get rid of by using elimination. So you could decide you want to get rid of the A's by making the coefficient, the number in front of the A, the same, or you could do the same thing for the B. Okay, let's get rid of the A's. Okay, so we're going to multiply all of this by the coefficient of this one, which is 4. So we're going to multiply that by 4, and we're going to multiply all of that with the coefficient of this one, which is 3. So we're going to multiply that by 3. So what does that give us? Well, the top one, equation number 1, when we multiply it by 1, it gives us 12a plus 8b is equal to 80. And equation number 2, when we multiply it by 3, we get 12a. So there you go, our coefficients are the same. Okay, but let's continue. Minus 3 times by 3 is minus 9b. And 12.5 times by 3, we can put that into our calculator. That gives us 37.5. So now we need to decide, how do we get rid of the a's? Do we add these two equations or do we take them away? Okay, so this is something that students often find it a bit of a struggle to decide whether to add or subtract. Okay, and usually the trick is this: if the signs are the same, so both of these are positive, then you take away. If they are different, one is positive, one's negative, then you add. All right, so in this case, if we were getting rid of the b's, okay, we would, and we had made the number in front of the b's the same, then we would have added. Right, so we are going to take away, so let's do our minus right there. We can just take it away as it is right there. Okay, so 12a, take away 12a is gone, it's 0. And now what happens here? That becomes a positive. So it's 8 plus 9. What's 8 plus 9? 8 plus 9 is 17, so we get 17b. And then we have 80, take away 37.5, and that gives us 42.5. Next, we want to find just b, so we're going to do 42.5 divided by 17, and that gives us 2.5. So b is 2.5. Now we need to sub b equals 2.5 into any of these two equations, either of them. Okay, just pick one. I'm going to pick number 1, so I'm going to sub it in here. Okay, right here. So wherever I see a b, right there, I'm going to put 2.5 in there. So therefore, into equation 1, and so I'm going to have 3a plus 2b. Now remember what b was? And that has to equal 20. b is 2.5. All right, so I just worked that out. So that's 3a plus 2 times 2.5 is 5. Equals to 20. Take the 5 to the other side. I get 3a is equal to 15. And therefore, now do 15 divided by 3. a is equal to 5. Now, your answers are there. But what if I made a mistake somewhere? This is a good idea to check. And to check, what you do is you substitute your a equals 5, your b equals 2.5 into the equation that you haven't used, which was the second one. All right, because you use equation 1 to do the substitution up there. Okay, so we're now going to substitute a equals 5 and b equals 2.5 into the second equation. All right, so we're going to 4 bracket, that's where a is going to go, minus 3 bracket, that's where b is going to go, and that has to equal 12.5. All right, so let's put that in. So 4 times a is 5. So 5 goes in there, and 3 times minus 3 times 2.5, that goes in there. So what is 4 times 5? 4 times 5 is 20, and 3 times 2.5, that is 7.5. So is 20 take away 7.5 equal to 12.5? Yes, it is. So 12.5 equals 12.5, and that means we are correct. So our answer, our final answer is a is equal to 5 and b is equal to 2.5. Question number 5. ABCD is a quadrilateral made from 2 right-angle triangles. Work out the size of angle X. Let's go highlight that. So that's what we find in. Give your answer to 1 decimal place. Right, so angle X is up here. Let's just also highlight that. That's what we want to find. Now, if you take this triangle right there. All right, let's draw this real quick separately. So it's isolated from the rest of the diagram. That's 10 centimeters. We don't have anything else other than this side here to help us work X out. Now, the topic, what's the topic? That's something else you need to identify. It's trigonometry. You're going to use SOHCAHTOA to find angle X. But to use SOHCAHTOA, you need one of the other lengths. Okay, you need either this length or that length. So this length or that length. Now, we can find this length right here by using the other triangle on the other side. Okay, so let's draw that one out separately as well. So if we use this 13 centimeters, that's right angle, and also I thought to include the right angle there. Can you see this triangle has got 2 lengths, and we need to find this third side, which is the same third side as this one. Okay, so what do we use for that? We can use Pythagoras' theorem to find that, okay, because we are finding lengths and we've got 2 of the lengths. So let's label it. That's going to be C. C is always the longest side and also opposite the right angle. And the other 2 sides we can call A and B. Let's just call this A and let's call this B. So using Pythagoras' theorem, we are going to have A squared plus B squared equals C squared. Let's now substitute our values in there. So A is going to remain as A squared and B squared is 5 squared is equal to C squared, which is 13 squared. If we rearrange that in terms of A squared, we take the 5 squared to the other side. You can work it out right there if you want to, or you can just take it to the other side. So 13 squared minus 5 squared, and that gives us 13 squared is 169 and 5 squared is 25. So if you now subtract them, we get 144, and the square root, because we don't want A squared, we want A. So the square root of 144, A is equal to 12 centimeters. So now that I have A is equal to 12 centimeters, this is now known. So this is 12 centimeters, because remember, A is this length right there, and that length is the same as this length right there, because that is the triangle that I've just drawn, okay? Now, let's go and focus on this triangle right there. So let's label this. Remember, I said we are going to use SOHCAHTOA to work this out, okay? So what do we have? Let's label our sides. So sides are labeled according to the angle, all right? So this is my angle, so this is my opposite side, okay? So this is op. This is the adjacent side, so this is adj. We don't need to label this one, but we can if we want to. It's called hypotenuse, okay? Now, we are dealing with adjacent and the opposite. If we look at SOHCAHTOA, what deals with adjacent and opposite? Adjacent and opposite is tan, TOA, okay? So we are going to do tan theta is equal to opposite divided by adjacent. So now let's go substitute our values in. Our theta is x, so it's going to be tan x is equal to opposite is 12 over the adjacent, which is 10. Now when you're finding angles, you need to do the inverse. So x is going to be equal to the inverse of 12 over 10. And what's that give us? If you put that into your calculator, that gives us 50.2 degrees. And don't forget, that was rounded to 1 decimal place. So if you didn't round appropriately, then you wouldn't get the full marks, most likely. All right, so question number 6 here. Here are 4 graphs. Write down the letter of the graph that could have the following equations in the table. For a question like this question is testing you on whether you know how to identify different types of graphs. So I'm not going to look at this just yet. Let's just go through the graphs one by one. This graph is a quadratic graph. It's going to have an x squared in it. B here is a linear graph. It's going to be in the form y equals mx plus c. This graph here is a reciprocal graph. It's going to be 1 over something like x. This graph here is a cubic graph. It's going to have a cube in it somewhere. So that's the way you're going to identify it. So if you have a look at the table now, okay, y equals mx plus c form. Can you see that? So that would be graph B. The next one, y is equal to x cubed, is going to be D. The one after that, the reciprocal 1 over x, is going to be C. So there you go. So you have linear, you have a cubic, and you have a reciprocal graph. Okay, so these are the different types of graphs. All right, so question 7. Here are 2 column vectors, A, 3, 1, B, -1, 2. On the grid below, draw and label the vector 2A plus B. So 2 lots of A plus B. So what does this mean? Well, very quickly, x and y are the vector. So what this means is the x up here is telling us how much to go in this direction, left and right. The y tells us how much to go in the up and down direction. So we have 2 lots of A plus B. So if we do this as an expression, so let's say 2 lots of A, so if A is 3, 1, plus B, which is -1, 2. Now let's work this out. Now this will multiply with the 3 and the 1. So it's going to be 6 over 2. Well, not over 2, 6, 2. And then plus -1, 2. Now we are going to add these. So 6 plus minus 1, that gives us 5. 2 plus 2, that gives us 4. So 4 is our full and total answer for this. So we need to go 5 across and 4 up. Now, because the 5 is positive, I've gone to the right. If it was negative, I'd go the opposite way. Same with the 4. Because the 4 is positive, I've gone up. If it was negative, I'd go down. All right. So let's just find a point here on our grid. Let's choose this as our point. So we are going to go 5 across. So 1, 2, 3, 4, 5. Okay, right there. And then we are going to go up by 4. So 1, 2, 3, 4, right there. So our full vector that we want to draw is in this direction. That is 2a plus b. And there's your final answer. Question number 8. Rob wants to install solar panels. Rob decides he will need 6 solar panels. Each solar panel costs £350. The other components required costs a total of £2,400. It will take 2 men 2 days to install the system. The labour charge is £150 per man per day. The average household with this system will save £1,200 per year on electricity. If Rob has this system installed, how long will it be until the money he will have saved will be equal to the initial costs? Give your answer in years and months. All right, so this question is very, very wordy, okay, as you can see. And you need to start at the top, start highlighting things perhaps, important bits of information, and, write things, translate the sentences, the words, into numbers wherever you can, all right? So let's go ahead and do that. So he needs, 6 solar panels? Let's highlight that. Each solar panel costs £350. So let's find out how much the cost will be, all right? So the cost will be 6 times by £350. Put that into your calculator. That gives us £2,100. So this is what the cost of that is. Now, there is, of course, a labour charge, all right? The labour charge is £150 per man per day. And you need 2 men over 2 days to install the system. So each man will be getting £300 over the 2 days. If you've got 2 men working on it, that is 300 times by 2, which is £600. So that is your labour charge right there, £600. But that's not all. It says that there are other components required which cost a total of £2,400. So now the other components. So let's do that here. So other components. And that is 2,400. So we will need to add all this up. These are the costs, okay? So 2,100 plus 600 plus 2,400, that gives us a total of £5,100. So this is the cost for Rob to install solar panels. Now, the average household with this system will save £1,200 per year on electricity. If Rob has this system installed, how long will it be until he will have saved the money that will be equal to the initial costs? So let's find out how many lots of 1,200s go in here. And to do this, we just divide. So it's 5,100 divided by 1,200. And if we do that, that gives us 4.25. So it's 4.25 years. That's when he's going to be breaking even. Okay, so that's what it asks us to do, because we just want to know the equal to the initial cost. So that is 4 years, and 0.25, we will multiply that by 12. So 0.25 times by 12 is 3. So it's 4 years and 3 months. And that's our answer. Question number 9. Make m the subject of the formula. Y is equal to 3m plus 4 over 5n. All right, so what do we want to make the subject? Let's go and highlight that. So m, we want m on its own. Okay, just like right now we have y on its own, we want to make m on its own. So the first thing we want to do is multiply this. Get rid of the denominator on the fraction. We're going to multiply that on the other side. That will give us 5, oops, not that pen. that will give us 5ny is equal to 3m plus 4, which we have on the numerator left. Now, I need to get rid of this 4 first. All right, a lot of students start looking at the 3. Don't look at the 3 yet. Okay, get rid of the 4 by taking it away on the other side because it's a positive there. All right, so that gives us 5ny is, not equal to, minus 4 is equal to 3m. Then we get rid of the 3. How do we get rid of the 3? What's it doing with the m? It's multiplying. So what's the opposite of multiplying? To divide. So now we have m on its own, and we're going to divide the entire side on the other side by 3. And that's our final answer. Question 10. The price of train tickets in 2020 was 3.5% higher than in 2019. The price of a ticket from Bristol to London in 2020 was £2.80 more than in 2019. Work out the price of a train ticket from Bristol to London in 2019. Let's go highlight stuff now. So this is important, 3.5% higher in 2020 than in 2019 rather. And the second one that's important for me here is the fact that in 2020, a train ticket from Bristol to London was £2.80 more. Okay, that's quite important. So where do we begin with a question like this? Let's zoom in a little bit here so you can see better. Right, so if we start off with that information of 3.5%, this is saying that it's 3.5% higher than in 2019. And we are told that this amounts to £2.80 in terms of money. So we can write down 3.5% is equal to £2.80. So if we want to work out the price of a train ticket from Bristol to London in 2019, what we want to do is find out what 1% is equal to and then go up to 100% from that. So to find out what 1% is, we divide by 3.5 and then we times by 100. Okay, so look, 3.5 divided by 3.5 gives us 1, and then we times that by 100 to get the 100%, which is the original amount. And we'll do that on the other side as well. So that's going to be divide by 3.5, and then we're going to times this by 100. So what is £2.80 divided by 3.5? If you do that on your calculator, you get 0.8. Now we are working in pounds, so it's going to be 0.80 like that. Then we times that by 100, and then that gives us £80. So the price of a train ticket in 2019 was £80. If we go on to the second part of this question, it says the price of train tickets increased by a further 3.5% per year for the following 3 years. Compound interest comes to mind, okay? So original amount times by the multiplier to the power of n is equal to the new amount. Remember that formula. A train ticket from London to Sheffield in 2019 was £130. Work out the price of a train ticket from London to Sheffield in 2022. So from 2019 to 2022, how many years is that? That is a total of 3 years. So the formula that we're going to use, like I said, is original amount times by the multiplier to the power of n, because of compound interest, is equal to new amount. So the original amount is £130. The multiplier for 3.5% is going to be 1.035. So 1.035 to the power of n, which is 3. And just knock that into your calculator and you get an answer of £144.13. So that is the price of a train ticket from London to Sheffield in 2022. Question 11. Izzy rolls 1 dice. Jim rolls 2 dice and adds the values together. Who is most likely to get a result of 6? You must show how you decide. This is a question for 4 marks. How do we begin this one? First of all, let's write down the probability of getting a 6. So probability of getting a 6. So on a dice, there are 6 different numbers and 6 is one of them. So it's going to be 1 over 6. So that's a probability of a 6. So if Izzy was to roll 1 dice, the probability that she gets a 6 is just 1 out of 6. But if we focus on Jim, Jim rolls 2 dice and he adds the values together, making things complicated for him to get a 6. We need to draw a table. So if we draw this table here like this, so let's have the first dice here and the second dice here. And the first dice's options are 1, 2, 3, 4, 5, 6. Second dice you can get also 1, 2, 3, 4, 5, and 6. All right, so which results would give us, when we add the values together, a total of 6? All right, so for example, if you get 1 on the first dice, then you get a 5 on the second dice, then that will give us a 6. Okay, so that will give us a 6 right there. Okay, because we add in the scores, 1 and the 5. And we'll keep doing that. Okay, and you look at all the combinations that you can do that for. So for example, if you get 2 on the first dice, then you need a 4 on the second dice to get a total of 6. Okay, so here is another example where you get a 6. Also, 3 on dice 1 and 3 on dice 2. That will give us a 6. So as you can see, there's a pattern starting to emerge which goes up diagonally like this. So 6, 5, and 1, that's also a 6. 5 combinations that add up to give 6 for Jim. So if we write down Jim, 5 combinations add up to 6. So Jim has 5 combinations that give him a total of 6. So if we look at one of them, let's just look at this one, okay, right there. He has to get a 4 on the first dice and a 2 on the second dice. What are the probabilities of getting a 4? What are the probabilities of getting a 2? Because it's a dice, it's a fair dice, you can say that the probability of getting any number is 1 out of 6, and means times, and the probability of getting the 2 is also 1 out of 6. This will be true for all the combinations. So if we work out one of them, so the total of that is 1 over 36, and then we multiply that by 5, so 1 over 36 times by 5, that gives us 5 over 36, and we can give that as a decimal answer, which is 0.1388 recurring. Now if we go to Izzy, remember Izzy's role was just to get 1/6, okay, and we work this out as a decimal, so that gives us 0.1666 recurring. Who is more likely, okay, to get 6? Whose probability is higher? Okay, so which number is bigger? Right there. Okay, you can see that this number here is bigger. So Izzy is more likely to get a 6. A score, a total score of 6. Remember, Izzy only rolls 1 dice. Okay, question number 12. The nth term of a number sequence is 2n squared plus 1. Write down the first 3 terms in the sequence. This is a question for 5 marks in total, parts A and B. Okay, so the first part is just 2 marks. So we've got the nth term of a number sequence right here. We're going to write down the first 3 terms. That's simply plugging in n equals 1, n equals 2, and n equals 3 into our formula. So if we do the first one, so 2 times 1 squared plus 1, and then we do the second one, 2 times 2 squared plus 1. Third one will be 2 times 3 squared plus 1. So go back and work this out now. So 1 squared times by 2 plus 1, that gives us 3. So the first one gives us 3. The second one, 2 squared is 4, times by 2 is 8, plus 1 is 9. 3 squared is 9, times by 2 is 18, plus 1 is 19. So our values, the first 3 terms is 3, 9, and 19. Part B, the first 5 terms of a different sequence are 3 over 1, 5 over 4, so on and so forth. Find an expression in terms of n for the nth term of this sequence. Now, when it comes to these questions, the top is done separately and the bottom is done separately. So you need to find the differences for just the top and work out what the sequence rule is, and do the same thing for the bottom. So let's start with the top. So what's the difference between 3 and 5? How do you get from 3 to 5? You add 2. And then if you do the next one, 5 to 7, you also add 2. And it's always add 2. So we can safely say 2n. That's the first part of our sequence. And then what do? We go backwards from the first term to the nth term by doing minus 2. What's 3 minus 2? 3 minus 2 is 1. So we add that 1 right there. Now we'll do the same thing for the bottom one. So 1 to 4, that gives us 3. 4 to 9, that gives us 5. So we can see straight away it's not going to be a linear sequence. Okay, let's continue doing it though. So 9 to 16, what does that give us? That gives us 7. 16 to 25, that gives us 9. So the bottom one appears not to be a linear sequence Could it be a quadratic sequence? To do that, we take the difference of the differences. So 3 to 5, what's the difference there? 3 to 5, the difference is plus 2. If it's a quadratic, the difference of the difference will be the same. So 5 to 7 is also plus 2. 7 to 9 is plus 2. What do we do now? We know it's a quadratic, so we halve the second difference. So 2 divided by 1. I have a video on quadratic sequences on the channel. Go and check it out if you need a bit of help on this. So let's just work this separately down here. So we halve the second difference, which is 1, and then we write an n squared next to it. We don't need to write the 1 there, but I've just left it there to emphasize that there's a 1 there. Then what do is we draw a table. So in this table, we write down the original sequence, which is 1, 4, remember it's just this we are looking at, okay, that's the original sequence here. So 1, 4, 9, 16 and 25, and then we write this 1n squared in the second column, so 1n squared. And how do we generate those values? Well, we put 1, 2, 3, 4, 5, 6 every time for the n. So 1 squared, so we can write down the term numbers up here. So the first term, the second term, the third term, fourth term and the fifth term. So each time to find the numbers here, for our n, we put 1, 2, 3, 4 each time. So 1 squared is 1, times by 1 is 1. So it's 1, the first term on that one. 2 squared is 4. Times by 1, still 4. 3 squared, 9. Times by 1 is 9. So we can do that for the rest of them. Now, we need to find the difference between the original and our 1n squared. So as you can see, we can subtract them and they all give us 0. Okay, so the difference is 0. So 0, 0, 0, 0, 0. If we were to do the rest of our linear, let's just follow it through. Okay, there is nothing. There's no difference here. Look, it's just 0. Okay, but what do we do normally? We write 0n, then we go backwards by taking away 0. It doesn't make sense, I know, which is still 0. Okay, so we can just add 0. So practically, we're not going to add anything to this at all. Okay, it's just going to stay as it is. But if we go back here, the answer to that, the rule, we're going to put it down. So it's going to be n squared. We don't need to write the 1 anymore. So our final answer for an expression in terms of n, for the nth term of this sequence, this whole sequence right here, is this, 2n plus 1 over n squared. All right, question 3, Katie and Nelly each have a combination padlock. Each padlock has 4 dials. On Katie's padlock, each dial contains the digits 0 to 8. Okay, that's Katie. On Nelly's padlock, it contains, each dial contains the digits 0 to 9. How many more possible code combinations could be selected on Nelly's padlock than on Katie's padlock? All right, so let's work out each of their padlocks individually. So let's look at Katie first. Katie first. So 4 dials each padlock has. So if I write down 4 spaces like this, okay. So Katie's padlock contains the digits 0 to 8. How many numbers is that though? Including 0, it's 9. Because 0, 1, 2, 3, all the way to 8 is 9. So she can have 9 different numbers in the first dial, 9 different numbers in the second dial, 9 different numbers in the third, and 9 different numbers in the fourth. Nelly, so let's look at Nelly's padlock now. Okay, so Nelly digits can be between 0 and 9. So including 0, there are 10. 10, 10, 10, 10. 10 numbers here, 10 different numbers here, 10 different numbers here, 10 different numbers here. So just in case, look, this could be 1, this could be like 2, 5, 7. But this could also be 2. This could also be 3. Do you understand? So 10 different numbers can go in there because padlock can contain between 0 to 9 digits. So now let's look at the number of possible code combinations that could be selected for Katie and Nelly. So let's start with Katie. So Katie could have 9 different numbers in the first one, 9 different numbers in the second one, third one, fourth one. So to find out how many combinations there are, we're going to do 9 times 9 times 9 times 9. And that gives us 6,561. That's how many different combinations Katie has. For Nelly, it's going to be 10 times 10 times 10 times 10. And that is 10,000 different combinations. So how many more possible code combinations could be selected. We just do 10,000, take away 6,561, and that gives us 3,439. So 3,439 combinations more on Nellie's padlock than on Katie's. Question number 14. Correct to the nearest millimeter, the length of a side of a regular pentagon is 3.8 centimeters. Work out an upper bound for the perimeter of the pentagon. Give your answer in centimeters. Right, we've got to be careful here because we are given measurements of the regular pentagon side as 3.8 centimeters, but we're told that it's rounded to the nearest millimeter, but the answer needs to come out as centimeters. So if we first of all just write down 3.8 centimeters, convert that to millimeters now, just to be safe. So that's going to be times by 10, so 38 millimeters, and then do our error intervals. Okay, so the upper bound would be 38.5 and the lower bound would be 37.5. Okay, now we are working out the perimeter of a pentagon. A pentagon has 5 sides. So 5 sides, the upper bound of those 5 sides will be to add them. So we are going to be doing 5 times 38.5, which is our upper bound. So we are going to be doing 5 times 38.5 using our upper bound. And that gives us 192.5 millimeters. But the final thing left is to convert that back into centimeters because our answer is required to be in centimeters. So we are going to divide that by 10 and that gives us 19.25 centimeters. And that's the upper bound for the perimeter of that pentagon. Now, one question some students may have on error intervals, and like I said, I have a video on this, you can go and check it out, is this. You know, some students are thinking, is it appropriate to use 38.5 as our upper bound? Because doesn't 38.5 round to 39? Okay, well, can you see this sign right there? This sign means that it's not equal to 38.5, okay? And if you look at that video, I'll show this in more detail. What this means is that it's actually 38.49999, everything just less than 38.5, because it's not equal to that, remember. Now, if I ask you the question, hey, what would you round 38, let me write this in a proper color. What would you round 38.49999 to? If I said, hey, round this to, you know, the nearest millimeter, what would you do? You can see, because that's a 4, you'd have to keep just 38, which is the same as that. All right, so this is why for this one we use equal to, but for this one we don't use equal to. Okay, we just write it like that. But we can still use this answer because this is practically the same number, isn't it? Because how many 9s can I add? I can add forever. It will still be rounded to 38, that number. All right, so you can go check it out on that video where I explain this in a little bit more detail. Let's move on. Question 15. Enlarge shape J by the scale factor of -2 from the center of enlargement 0, 0. Now be mindful here, it's a negative scale factor, -2, which means you're going to go the opposite direction. All right, so if we use our center of enlargement for this first point right there, the first point going 1, 2, 3, 3 across. So that means it's going to be going times by 2 first and then going backwards. So 3 times by 2 is 6. So it's going to go backwards 6. So 1, 2, 3, 4, 5, 6. This is where it's going to be. So going up now, it's going up by 1 times that by 2. It's going to be going down by 2. So it ends up right here. Okay, so we're going to draw. So once again, we're going to draw 1, 2, 3, 4, 5, 6. Go down by 2 right there. That's where we're going to mark it. You could do that with all the points, okay? Or you could just, you know, start drawing it here with the scale factor done. But let's just go through all the points, all right? So a bit more practice. So let's do this one here. So 1, 2, 3, 4, 5. 5 across. That means times that by 2 and go 10 backwards, because 10 times 2 is, 2 times 5 is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right there. It's going up by 1, so we're going to go down by 2 right there, okay? So our second point is there. Third point, 1, 2, 3, 3 across, which means 6 the other way. And then 1, 2, 3, 4. 4 up, 8 down the other way. Okay, so let's do that. So 1, 2, 3, 4, 5, 6, and then down by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Right there, we're going to mark it. Okay, and then we just get a ruler and join this like that. Let's just shade it in for fun. All right, so that's our shape. Question 16, Paddy has 2 jugs of lemonade. Jug A contains 600 milliliters of lemonade, which he made using syrup and sparkling water in the ratio 1:3. Jug B contains 1.4 liters of lemonade, which he made using syrup and sparkling water in a different ratio. Paddy mixes the 2 jugs of lemonade, giving him a total of 2 liters. He calculates that the ratio of syrup to sparkling water in the mixed lemonade is 11:29. Work out the ratio of syrup to sparkling water for the lemonade that was in jug B. Wow, another very, very wordy question. All right, so the questions like this will frighten so many of you. You need to learn how to scaffold, okay? So you need to practice this scaffolding. So the more papers you watch, I show this, going through, reading a second time, highlighting things, all right? So let's go ahead and do that. So highlighting, jug A contains 600 milliliters of lemonade. And that is made in the ratio of syrup and sparkling water 1:3. Okay, so that's important. We have a different color pen. Jug B contains 1.4 liters of lemonade. You see, as I'm highlighting and I'm reading this second time around, I'm thinking, look, they need to be in the same units, stuff like that. That's the kind of stuff that you should be thinking of as well. All right, so continue. Syrup and sparkling water in a different ratio, and I don't know what that different ratio is. All right, so Paddy mixes the 2 jugs of lemonade and it gives him a total of 2 liters. He calculates that the ratio of syrup to sparkling water in this mixed lemonade, all right, is in the ratio 11:29. Work out the ratio of syrup to sparkling water for the lemonade that was in jug B. All right, so like I said, let's go back and start doing things that came into our head earlier, all right? So the first thing was the 1.4 liters of lemonade. That is 1,400 milliliters. So I can write that there. The 2 liters right there, that is 2,000 milliliters. All right, so I've got everything. I'm trying to convert things, break things down as and when necessary. Now let's go back to jug A here. Okay, so jug A, we know syrup and sparkling water, W, is in the ratio 1:3. And 600 milliliters of lemonade was made. Okay, so this represents 600 milliliters. So one thing we can do is to work out how many milliliters of syrup there was and water there was. We can break this down into 4 parts because 1 and 3 is 4 parts. So we can divide that by 4. So 600 divided by 4, that is 150 milliliters per part. So therefore, we can do 1 times 150 and 1 times, 3 times 150. So 1 times 150 is 150 milliliters and 3 times 150 is 450 milliliters. Okay, so this is how much syrup in jug A in milliliters and water, sparkling water in milliliters. Do the same thing for jug B. Okay, so for jug B, we do the same thing. So syrup to water. Now, what do we know about jug B? It's 1,400 milliliters, but we don't know the ratio, so we can't go any further with that just yet. Okay, so instead we'll look at the final, the 2 jugs being mixed, which gave 2,000, and that was 11:29. So I'm just going to create some space quickly by shrinking this down a little bit. So let's look at the mixed jug now. Okay, so in the mixed jug, the syrup to the water, and this was 2,000 milliliters, it was in the ratio 11:29. So we're going to do 2,000 divided by the total of 11 plus 29, which is 40. So we're going to do 2,000 divided by 40, and that gives us 50. So 50 milliliters per part. So it's going to be 11 times the 50 and 29 times the 50. So 11 times by 50, that gives us 550 milliliters of syrup, and 29 times by 50 gives us 1,450 milliliters. Let's just put a box around that so it's not confused and fix that a little bit. So 1,450 milliliters. Right, so this is what we know from the mixed jug. Now, remember, we're trying to work out the ratio of syrup to sparkling water for the lemonade that was in jug B, which is right over here. So the next part of this is going to be crucial for you to understand. So pay attention to this. Let's make that smaller there. Let's first focus on the syrup. Okay, let's focus on the syrup for now. Okay, so for the syrup, we know that the final version was 550 milliliters. How much of that comes from jug A? From that is 150. So for the syrup, we are going to do 550 milliliters, take away the amount that came from jug A. That leaves us with 400. So that means 400 milliliters must have come from jug B. So we can go here now and write 400 milliliters. All right, and we'll do the same thing for the water. All right, we have a total. How much of that came from jug A? Well, 450. So 1,450 milliliters, take away 450 milliliters, and that leaves us with 1,000 milliliters, which we know now must have come from jug B. Okay, so for jug B, let's shift this a little bit. For jug B, you're going to have 1,000 milliliters of water. So the ratio now that you're looking for, simplified. If you want to simplify it, actually, do you need to work out the ratio of syrup to sparkling water for the lemonade? No, you don't need to simplify it. So this is the ratio, 400 to 1,000. But let's simplify it. Let's just assume it would say, in its simplest form. So what do you do to simplify 400 and 1,000? You need to divide it by something, okay? So we can cancel out, we divide by 100 first, so we get 4 to 10, and then divide it by 2, so we get 2 to 5. So our final answer is 2 to 5. All right, so take it all in, guys. Lots of details in this question. There wasn't much working space, so I had to squash everything in, but I hope you understood all that. Okay, go and rewind if you need to just follow it again, because I was writing everything all over the place, so some of you may be confused when you look at the entire thing. Question 17. Solve 4x squared is equal to 8x plus 7. Give your solutions to 2 decimal places. Now this indicates to me that you will be using a calculator. Of course, it's a calculator paper. Therefore, if you're dealing with what? A quadratic, you're going to be using the quadratic formula. So the first thing you want to do is rearrange this. Okay, so rearrange it in the form ax squared plus bx plus c equals 0. So we're going to take the 8x plus 7 all over to the other side, giving us 4x squared. We want to keep the x squared positive. Minus 8x minus 7 equals 0. And then we write down the values of our a, our b, our c. So our a is 4, our b is minus 8, and our c is minus 7. So the quadratic formula, what is it? Is x is equal to minus b plus and minus square root b squared minus 4ac all over 2a. So we can just plug that in now. So x would be equal to minus b. What's b? b is minus 8. Plus and minus square root. What's b squared? Minus 8 squared. Minus 4 times a is 4, so 4 times a times by c, which is minus 7, all over 2 times 4, there we go. Then we just go and simplify things. So for example, this here will become a positive 8. Here we'll have 8 squared, minus 8 squared, sorry, so minus 8 times by minus 8, which is positive 64. Okay, here we'll have 4 times 4 times 7, but be aware there's 2 negatives here, so the overall answer from just this will be a positive. And of course this would be 2 times 4, which is 8. So this is a very important step. Please simplify. Okay, so x would be equal to 8 plus and minus square root 64 plus 112 all over 8. Let's just make this a little bit tinier so we've got room to work. Okay, there we go. All right, so now the next step is to work that out. So let's just go and simplify that a little bit more. So 8 plus and minus 64 plus 112, that gives us 176 all over 8. So we will have 2 versions to this. The first one will have a positive and the next one will have a negative. So on your calculators, type in 8 plus root 176 all over 8, and then 8 minus root 176 all over 8. So you should have two solutions. The first one would be 2.66 to 2 decimal places, and the next one would be x is equal to minus 0.66 to 2 decimal places. And there you go, that's your final answer. Part B for 3 marks, solve 2 to the power of x over 2 to the power of 3 is equal to 32. So what we can do here is we can make the 32 have a base of 2, and that would be 2 to the power of 5. And then we can write the other side as it is. And then we can simplify this. So we have two things which are dividing, so therefore what do we do with the powers? We take them away. So we can do 2x minus 3 as one single power. So we can write this as 2 to the power of 2x minus 3 is equal to 2 to the power of 5. And now that we've got the bases the same, we can drop the powers down or make them equal to each other. So we'll have 2x minus 3 is equal to 5. And now we've got a linear equation. So therefore, we take the minus 3 to the other side. So we get 2x is equal to 8. And then divide by 2, so x is equal to 4. And there you go, that's your answer. Question 18. The table shows information about the speed in miles per hour of some cars as they traveled past a speed camera. Draw a histogram to represent this information. What do we need for our table? We need a frequency density column. All right, so let's go ahead and add that. So extend your table. There we go, that's our frequency density. And then of course you need a formula. So frequency density is equal to frequency divided by the class width. So to find what goes in here, we're going to do frequency divided by the class width. So the class width here is 30. The class width here is 5. The class width here is 10. The class width here is 15. Okay, so we're going to do 12. I'll do one of them divided by 30, and that gives us 0.4. Okay, I'll do one more actually. So that's going to be 22, the frequency divided by the class width, which is 5, and that gives us 4.4. Then we've got 34 divided by 10. 34 divided by 10 is 3.4, and then 3 divided by 15, that gives us 0.2. Okay, now if you look at our graph, usually the frequency density may not be marked for you, so you'd need to figure out how to break it up, okay? But they've been quite generous, they've already given that to you, okay? Right, so we want to plot the first one. So 0 to 30, frequency density of 0.4. So 0 to 30, this is how wide our bar is going to be. Okay, we're going to go up to 0.4. So on the y-axis here, we're going to have to find out where is 0.4. So this appears to be a box which has going up in 2s. So we need to find out where 1 is first. So count how many squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So that means 5 squares. 1, 2, 3, 4, 5. 1 is right there, halfway right there. Okay, that's 1. Okay, we can do that for all of them if you want to. All right, to help you out. What does your thing go up to as well? 4.4. Okay, so we don't need to go too high. 1, 2, 3, 4, 5. There's that. There you go. Okay, so there you go. Now, what we're doing quickly, I'm going to be zooming, in and out. So just make sure you've, got that table down. So 0.4 between 0 and 30. So 0.4 between 0 and 30. So there's 30 here. We're going to go up to 0.4. So each one of these now is 0.2. So 0.2, 4, 6, 8, 1. Can you see? So 0.4 is there, right that. Okay, so up and across. That's 0.4. That's the first one done, okay? The next one is 4.4 between 30 and 35. So 4.4 between 30 and 35. Again, we're going to need to find 35 now. So that's going to be halfway. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore halfway for 35. So 1, 2, 3, 4, 5 right there. Okay, that's 35 right there. Okay, so we're going to go up to 4.4. So up to 4.4. Let's get our ruler. So 4 there, 4.2, 4.4 right there. Do the same on the other side. Go across. There we go. And then we have 3.4, and that's between 35 and 45. So between 35 and 45. So again, we need to find where 45 is. That's 45, and that's going to be, what was it again? 3.4. So 3.4. So up with a ruler. So that's, we're on 3 right there. So 3.4 there. Go across all the way and touch the other side, and there we go. And the last one is 0.2 between 45 and 60. So between 45 and 60, which is the last one, 0.2, which is simply just that little tiny one right there. Okay, so that's my histogram. We can color this in as well. Let's just color that in. So there. You don't have to do this. It's just to make it look pretty. And it's quite therapeutic actually on the iPad. There you go. Okay. You don't have to do this, like I said, all right? But it does make your lines stand out. Okay, there. That's your histogram. And that was for 3 marks. Now, this is where a bit of the AQA style of questions come in. What do you think the speed limit is on the road? Tick the appropriate box and give a reason for your answer. Now, we have to look at our histograms for this. So what is the speed limit? What did most of the cars, what speed were they recorded as doing? Because that will indicate to you what the speed limit should be, okay? So we are looking for the majority. Now, on a histogram, if you want to find the majority, the most common frequency, you can look at either the histogram, or you can even look at the table actually for this. You can see that the majority of the cars were around here. Okay, so the speed limits were between 30 and 45. Obviously, it's going to be one of those. Okay, so we know that the speed limit is somewhere between 30 and 45. Now, what are options? Remember, it's between 30 and 45, but if you look at the options, between 30 and 45 would be here. Okay, but we can only pick one of them. So go back to the graph or the table again. This one has the highest frequency. Okay, so it has to be between 35 and 45. So therefore, the only option that's here between 35 and 45 is 40 miles per hour. So there you go. And the reason, I've explained it to you, but you could say something like most cars are between 35 and 45 miles per hour, as according to the table. According to the table. Okay. Okay, question number 19. This is a total of 5 marks. Okay, part A is 2 marks. We'll look at part B in a second. Let's just zoom into part A for now. So here is a cone. Work out the volume of the cone. So the volume of the cone formula is 1/3 pi r squared h. So we just need to substitute our values. So V is equal to 1/3 times pi. Our radius is 5, so 5 squared. Our height is 12. So we can knock this into our calculator and we get 100 pi, or we can use this in decimal form, which is 314.2 centimeter cubed. And of course, this is also in cubed as well. So either of those answers are fine. Now part B, it says a larger cone is mathematically similar to this cone. It has a surface area which is 4 times greater than the surface area of this cone. Work out the volume of the larger cone. Give your answer to the nearest integer. So we have 2 cones, cone A and cone B, which we can call the larger one. And the surface area of cone B is 4 times greater. So if we call this one 1 and 4 times greater, 4 times as much would be 4. So this is our surface area. In other words, our area ratio. Okay, so we need to find out the volume. Okay, so we will go down to the length ratio, because from the length ratio we can go and find the volume ratio. In order to do that, we square root both of these. Okay, so we square root 1 and we square root 4, and to work out the length ratio, that gives us 1, 2. So this is the length ratio. This is very important. From the length ratio, we work out the volume ratio. How? We cube it. So that would be 1/8. And this is the volume ratio that we will need to use. All right. Do we know the volume of cone A? Yes, we do. We worked it out earlier. It was 314.2 centimeter cubed. So the volume of cone A is 314.2. Do we know the volume of cone B? Of course not. That's what we're trying to work out. So we're going to call that x. Now we set up a ratio using this. Okay, so we say 8 over 1 is equal to x over 314.2. So that would be 8 over 1 is equal to x over 314.2. Then we just rearrange this and make x the subject. Okay, so what do? We can take this over onto this side, and that's it. So it would be 8 times by 314.2. We don't have to do that divide by one thing, but you can keep it there if you want. So what's 8 times 314.2? That gives us, for x is equal to 2513.6 centimeter cubed. Now I think the question said to the nearest integer. There we go. Yep. So to the nearest integer, x would be equal to 514 centimeter cubed. So that is the volume of cone B. Okay, the penultimate question, the one before the last. Prove that 2n bracket n plus 4 plus n minus 4 all squared is positive for all values of n. So this is a proof question. Let's go ahead and expand first of all, so we can expand. So this bracket gives us 2n squared plus 8n. This bracket here, we're going to put into another bracket, so some of the negatives may change. So that will be n squared minus 8n plus 16. And then we collect all the like terms. So that would be 2n squared plus 8n plus n squared minus 8n plus 16. So the like terms here that we collect is this one and this one. That gives us 3n squared. And then the 8n and 8n will cancel because one's positive, one's negative, and we're just left with plus 16. So how do we prove that it's positive for all values of n? Well, we just have to look at this. So what does this do? If you square something, when you square something, you always get a positive. And you're going to times this by 3. So you're still going to get a positive value overall. And then what do you do after that? You're adding a positive number. So you're adding a positive number to an already positive number, and therefore you're still going to end up with a positive value. So there you go. That's your proof that you get a positive value for all values of n. Question 21 and the final question. A helicopter flies 18 kilometers from the airport A to point B on a bearing of 035 degrees. The helicopter then flies from point B to point C on a bearing of 130 degrees. Finally, the helicopter flies back to the airport on a bearing of 250 degrees. Work out the distance from A to C. Give your answer to one decimal place. We need to draw this, okay? So let's start off with point A, which is where it's all happening. Okay, look. And then we first want to highlight which way is north. And a bearing of 35 degrees would be around going in this direction right there. Okay, that's 35 degrees. So we're going to call that 35 degrees. And then it's 18 kilometers that it travels, because it says it flies 18 kilometers from the airport A to the point B, which is right there. Now we also need B's north as well. That's quite important. This then says that the helicopter flies from B to C on another bearing of 130. So this 130 needs to be from here itself, okay? All right, because it's flying from there, from point B. So where is 130? It's going to be something down here, along here, okay? Okay, anyway, like you can go as long as you want. It doesn't actually say for how many kilometers it goes. So it can be a line like this, it can be a line like that, we don't know. But we know that we're going to be dealing with triangles, so try to keep it close by, okay, to point A. All right, but it doesn't really matter even if you don't, okay? So let's just stick it somewhere here for now. A bit longer actually, because I'm going to need a nicer triangle. Okay, there. Finally, the helicopter flies back. So this is C. This is C. It flies back from to the airport on a bearing of 250. Obviously, where's it flying back from? It's flying back from C. So now we're going to need to draw C's north. All right, and 250 degrees is, well, let's first of all draw the line from C to A first, all right, to go back. So look, there, okay? So we know that this right here is 250, Okay, that's 250. Because remember, bearings are 3 digits from north, always from north, and they go clockwise. So they have to go clockwise like that. Okay, so that's 250 degrees. All right, and there we go. So what we're trying to work out is the distance from A to C. So the distance of that's x. So can you see this triangle now? We are going to be looking at this triangle. We're going to give our answer to one decimal place. So let's just have a closer look at this. So let's draw this triangle without any of the bearing stuff on it, okay? So here, okay, so that's going to be A, B, and C, all right? So what do we know? We need to work out one angle at least, okay? Because we've got a few things. We've got 18 kilometers here. We're trying to find out what x is right there. So we need a few things here, all right, that we can work out. So if we go back to this diagram, we can work those out. So these are two lines, two parallel lines. So this angle here can be found by doing 180 minus the 35, all right? So this angle right here would be 180 minus 35. Okay, so 180 minus 35, that gives us 145 degrees. So this is 145 degrees, all right? Now, I forgot to do this earlier because I don't know why. So this is 130 degrees because it said from B to C is 130 degrees. I should have put that in earlier, I didn't. I'm sorry about that, but it's there now. So therefore, what's this angle here? Well, this is going to all equal 360. So if I want to work out this angle here, and that's exactly what I need, all right, I can find it, okay? So this angle right there would be 360 minus 130 plus 145. And that gives us 360 plus that gives us 85 degrees. So we can write in here 85 degrees. So we have that. Now we can also find this angle right there. Again, using the same rule that we use for these two, okay? So these are two lines which are parallel. So these two angles are going to equal 180. So again, this is going to be 180 take away 130, and that gives us 50 degrees. Now, see why we did this? We can find this angle right there, okay? Because we know this is 250. We now know that this is 50. So to find out what this angle right there is, we're going to do 360 minus 250 plus 50. And that gives us 60 degrees. So this angle right there is 60 degrees. Now let's go and populate all of those angles in here. All right, so we know that this is 85 degrees and this is 60 degrees. Now, why did we do all this? Okay, let's just go down here. Why did we do all of this? How does this help us? Well, now I can use the sine rule to find the side x. I have two pairs of opposite angle and sides. I have two pairs of opposites where I have the angle and the sides. So I can use the sine rule. All right, so let's just get rid of that. So the sine rule is as follows. I'm finding x. So it's going to be x over sine 85 is equal to 18 over sine 60. Then I rearrange by taking the sine 85 to this side. So I have x is equal to 18 times by sine 85 all over sine 60. Okay, and then I just put that into my calculator and I get 20.7, and that's kilometers. So the distance between A to C is 20.7 kilometers. And that brings us to the end of this lesson. I hope you enjoyed this lesson, guys. Please do give this video a thumbs up. Please share it with others. It helps me. It helps motivate me to continue to create good quality videos like this to help you along your journey of GCSE and A-level maths. Bye for now, and I'll see you in the next one.